I know it's been a very long day, and this is going to be a slightly bit of a technical session. But Nicole reiterated some beliefs that I've had in terms of not only generating evidence, but then taking that evidence to a point where we can form publication-ready material. And as you may have appreciated walking through Patrick and Martine's presentation, is the idea of being able to execute a large number of comparisons across a number of different analytic designs, across a whole database, across a whole network of databases, leads to an unruly, thank you very much, no, it's all good, this is what it's for, really does lead to kind of an unruly amount of information, and that information somehow needs to be synthesized down into a publishable story. And honestly, I think OHDSI as a community has abjectly sort of failed in that last step. And in many ways, I say the community has failed, but it's more like I have failed since I've spent sort of the last 4 years trying to build a large clinical community within OHDSI that is able to take those last steps of kind of synthesis. So we're just going to start today with a couple of the preliminary steps to sort of skill us up a little bit in how to start taking care of that synthesis problem. As you've probably noticed, for better or worse, most of the tool stack within OHDSI is wed within R. There are some real advantages to that and some real disadvantages. Not to give the impression that it's all R. There's a huge amount of JavaScript under there too, in terms of the, kind of the web applications. However, most of the evidence generation, so the analytic tools and the results themselves are easy enough to access through R, or if you know what the underlying representation is, kind of any other statistical platform that you'd be interested in using. So the first 2 steps that one might take to think about, I've run a study, for example, the SOS challenge. I'd like to be able to move through the result sets and make some figures and tables, are kind of starting with both a setup for R and then an installation of some of the underlying packages that we have. And so this web page that I have up here is, I'm going to keep up, and it's going to be available to everyone. So you might want to pull it up yourself, including your R Studio itself, to SOS tutorial. And there's a little bit.ly that should be active for quite a while. And that will bring up the page that I'm going to walk through. There's also another one with the strategist data model that we'll get to, but that's linked to through the initial one. So please let me know if anyone has any challenges bringing up this page. Who before has run through our, the OHDSI webpage kind of that Martine and I put up in terms of, setting up R on your system? Has anyone had an opportunity? You just did today, which was wonderful. There's some very good advice on kind of how to set up a working environment. And this is both for, dealing with the result sets themselves, but also for running, for setting up your analytic platform on which you want to execute the OHDSI studies. Many of the packages that we'll go through today are components of a software library called Hades. Hades itself, all of the packages can be installed all at once. Today, we won't be using all of them. I'll just be using a couple which are good to get familiar with. In particular, the tutorial that we'll be going through out of Hades will use something called Database Connector, which is an R package that simplifies a connection to a SQL database and is used throughout our analytic platforms. SQL Renderer, which is a way of taking some very simple SQL statements in kind of a generic variant or a generic language and translating it into various platforms. For example, I work within the US Department of Veterans Affairs, and we're kind of tied to Microsoft SQL Server. I also work closely with Patrick and Martine and J&J, and they're kind of a Redshift shop. And across the network, we have a number of different variants. So this is kind of a way of just speaking one dialect, and then executing across many. When you get a chance to run through this web page, and I suggest you do, it might not happen in real time, these are just the underlying packages that you'll end up needing, and they happen to all be available on CRAN, so you don't have to go through the Hades setup. There are some credentials that were being emailed around, and I like to keep those credentials encrypted on the computers that I'm using, and in this way I don't end, when I share my R scripts for either running studies or generating the analysis, I don't accidentally share protected information. So you might see the file that you get is using a package called keyring, which takes tokens like the username, the login, what the servers may be, and encrypts them in your system. So the first thing that you would execute in kind of the credentials.r file that's being sent around is these simple commands. The key set with value basically takes whatever the information that you'd like encrypted and gives it a visible key to it, which you can then include in your files. You may have been very overwhelmed with the realm of different analytic approaches that one can take using the strategist framework. There was, within characterization, there was coming up with patient features at kind of index time. There are ways of getting index rates of different events, comparing different cohorts, all the way to the estimation types of problems that we might want to look at for comparative effectiveness and population level prediction. And there were statements that were made of, well, we've sort of standardized this, so there's a standard way of specifying what type of analysis you want to run, and then there's kind of a standard representation of what these result sets look like. But that was sort of when Patrick went very quiet, because what we haven't done across the community is done a very good job of kind of publicizing what that standard result set looks like, how you would access it, and how you would manipulate the different results to pull out the specific comparisons or analyses that you were really interested in. Starting with the starting with the two legend studies and now with the SOS challenges, we've started to formalize how these results are held in a common data model and where they're actually held. So it turns out that for the SOS challenge we'll go through today, all of the results coming out of the different strategist modules are held on a public database server that OHDSI supports. It's actually called ShinyDB because we initially deployed it as kind of a back end to OHDSI's Shiny results and haven't given it a terribly good name. I only realized about 3 weeks ago that nowhere does there actually exist a specification of the data model for each of these different for each of the different analyses? So one of the first tasks I took for you and also for the community was to start to summarize sort of what that data model looks like for each of the different strategist modules. So before we'll get to the data model, I'll talk a little bit about accessing the database. So this will then tell you, how to access the different tables and then a description of what the tables look like. So each of these strategist modules can be accessed on the ShinyDB server. It's important to remember that the ShinyDB server actually runs Postgres. So when you try to communicate with it, you'll need to have the underlying Java JDBC connections for the Postgres server. You can download the Postgres JDBC drivers using Database Connector. And so what you would do is, you can specify in your environment where you would like Database Connector to store its drivers. And in this directory, you might also have the local drivers to whatever your OMOP CDM might exist. So, for example, in the VA in this directory, I would also have the SQL Server drivers. So you can use Database Connector itself to go ahead and download the Postgres driver. Once you've done that, you now have all the tools you need to communicate with, which basically means get, use, analyze, help publicize all of the results from the SOS challenge. Database connector for connections takes two separate steps. The first is specifying your connection details. So under your connection details, you would say, I do want to connect to a server that uses Postgres. The server name, again, is one of those encrypted keys that was emailed around. It actually runs on Amazon on the US East. And then a username and password. And these usernames, these users and their associated passwords are generated for different schema within this database server. So for example, the SOS challenge, for each of the 4 different SOS challenges that we executed, there are 4 different schema. There's one particular schema called quinolone AA, which has all of the result sets for Jack's study looking at fluoroquinolones versus alternatives for a risk of aneurysms and dissection. The other big one that I've been involved with was led by an ophthalmologist in the US, which was looking at basically stabbing people in the eye and injecting anti-VEGF inhibitors and the potential kidney risk that might entail. For example, the LEGEND studies, LEGEND Diabetes has a schema name, LEGEND _ type 2 diabetes, and hypertension is LEGEND type 2 hypertension. Under each of those schema are the result sets from each of the different strategist modules. And we're not going to go through each of the different data models from each of the different modules, sort of table by table, but I do want you to know that we do have an almost full specification of the types of tables that you would expect. And to kind of give you an idea, after you run a characterization module, there will be a table called cohort counts, where within that table there are person counts by database ID and cohort definition. So you can begin to imagine, if I wanted to collect how many patients are in each of my target and comparator cohorts for Jack's study, I would look at the cohort count table and I'd be able to specify the specific cohort given its definition ID that I'd like to pull out, for example, those who are fluoroquinolone users, and then I could stratify by database ID to give me the number of individuals in each of those. What this document is currently missing, of course, is a human-readable description of each of these tables, and I need to go back to the developers of each of the modules to make sure they provide that. Martijn and I tried to provide a very good example by having that human-readable information for the schema for LEGEND, but apparently it didn't carry over. So to let you sort of see that, yes, you can be doing this in real time and it does actually work, I will just do one particular example. You'll notice the first set, we're defining the connection details. And finally, we're going to I'm going to retrieve some of the data from the fluoroquinolone schema, and I'm just going to collect, open a connection to this public database server, and then I can query information from it and use that. And we'll look at exactly what this is doing in a minute. But as we go along, please try some of these commands. So the first step you might want to do is, very simply, retrieve some of the metadata for a particular study. For example, we might be interested in what are the data sources or databases that are involved in Jack's study. And in order to do that, I'm going to demonstrate a simple query into our public server using both database connector and SQL renderer to connect that information. Things are held in a SQL database. So if you're familiar with using SQL commands for picking out specific data elements and doing table joins, so pulling information across tables in SQL, that's probably the most efficient way of doing things. Up until a couple of years ago, the most SQL that I knew was like select star from table name, and which basically, if you don't know what that is, that's give me all the information in this table, and you can do it for each of the different tables. It's a starting point I've been at for many years. You can do this type of data manipulation or the joins in R itself. You can just pull down the information. It's kind of up to you, and it comes down to sort of what is going to be the relative efficiency. In the result sets, most of the tables are trivially small. There are some that aren't, so you can do select star without much impunity. So the example that I had started to show that you can go through says we're going to be looking at the fluoroquinolone schema. I'm going to open my connection to the public ShinyDB server, and from that server, I want to collect or select all of the information from some meta command that I'll fill in the schema, and I'm going to replace schema with whatever the R value is. So SQL render allows you to template your SQL statements, so I don't have to rewrite them if I were going to then execute the same command against a different study. I could just change the variable itself and pull all of the information out of the database metadata information. And then I run that query and I close my connection. And so we can look at what are the names of the columns for the metadata table. And of course, it pulls out the same information that we would have gotten in the data spec model that we have themselves. To give you an example of selecting specific information out of that table using R instead of SQL, I particularly like the dplyr package. So this comes from the tidyverse. In the back end of dplyr, it actually converts composition of functions. So I have one function calls another function. It converts that to the underlying SQL and executes the SQL itself. So I can take the whole table and I can say, just give me the columns that have both the source abbreviations, right, and the database ID numbers. So at least I can have an idea of, the abbreviation that I might recognize and some integer value that disambiguates them across all different sets, right? I could have done this back in my select up here by just selecting those columns. And then I take database name and I can render them out. The first thing you might notice is these database names don't look very publication friendly, right? Some of them are in uppercase caps, some are in totally lowercase caps, others are extraordinarily long. So at this point, it's probably a good idea, if you're thinking about putting tables and figures together for a publication, to start to strategize what labels that are relatively uniform in length and informative would you be interested in using in your tables. So I've just done that manually. So, given these stored information, I've said, actually, I want some short database names in this that I'm going to use, and they're going to end up looking very pretty. And I've sort of standardized them as much as I could. Right. Likewise, you'll find that when you retrieve the cohort names, particularly cohort names that have been made from individuals working for Johnson & Johnson, because they have a habit of including all of the information about a cohort in the cohort name, you probably also want to recode those as well. So as an example, we can again connect to the public server. And in this case, I just want to pull out the unique cohort ID numbers and their cohort names. And in this case, I'm going to pull them from the cohort generator module and its cohort generation table. And so I execute this query, and then I can close my connection. Now, I mentioned that those aren't very user-friendly, and we'll take a look at what they look like. So it's now that I've pulled this information, it's easy in R to generate a dynamic table, right? And the cohort IDs are the numbers that we need to keep track of. But look at the cohort names that are stored in there are not things that I'd want to use as labels in any of my publications, right? So I've gone ahead and created some very sort of reader-friendly names, and attached those names to the two columns that I pulled out of the database. Notice I can reorder them alphabetically for description based on kind of these short names, right? So we have AA for aortic aneurysm, or dissection, FQ as we might use as a label for fluoroquinolone versus the half bactrim. And the UTI. These are sort of arbitrary decisions but are going to make things look a lot more user-friendly. Let me stop at this point and ask where people are and questions that this might have raised before we move on to some basic queries that you'd actually want to do for the results set.
When I ran the source abbreviation, I had 17.
Yeah.
So I made my own abbreviation.
Yeah, and so we will what one needs to put those in, right? And yeah, absolutely. Well, good. So it is working. Perfect. That's a huge success. Yes, I ran this a couple of weeks ago. Yeah, it's all good. Yeah. So make up some good ones, and there'll be more databases, and we'll be. And the nice thing about having a reproducible document that pulls this information out is we've gone ahead and we've created these figures that work just great for the 11 data sources that were there when I ran it. We now have a reproducible document. You just hit run again, and it will regenerate for the updated data. I'm going to start with some very simple queries that you might want to use, particularly in terms of like tabulating your cohort sizes. And so we'll start with a query directly from the public server, and hopefully end up with some sort of beautiful, useful table kind of at the end. So I'm going to start by connecting to the database server, and in this case, I'm just going to select from the cohort generator cohort count table the database ID column, the cohort ID column, and the number of subjects that correspond to each cohort in each database. And I'll run that query. And when I run that query, I will then do some joins in R to attach the more user-friendly, reader-friendly information, sort of the short names that we've already pulled out, right? So I'll join that table itself on database name, right? By with my database name table with database ID, right? So that adds to the table the nice reader-friendly descriptors we now have for each of the databases. In addition, I'll join on my cohort name table by the cohort ID. So this now adds sort of the user or reader-friendly IDs for the cohort names. Out of this, I'm just going to select the columns that I might want to put in a table. Like I might want these short cohort names that we've defined, the short database names that we've defined, and of course the whole reason that we were touching the data in the first place, how many subjects were in that database for that particular cohort. To make things a little pretty, I'll rename some of those columns so I don't have to type as much, And then I'll sort this table by cohort name and database name. And then I'll close. And that gives us kind of all of the information that we need to start generating our first table 1. How many subjects were there in this particular study across these things? I'm going to give a couple hints of ways that I use R to help create some more beautiful tables. The first way that I do is I never create a table in Microsoft Word. I think Microsoft Word table support is horrible. I personally believe that if you submit a publication that looks publication ready and publication quality, it's probably more likely to be accepted. That's just a personal belief. I have no evidence to the contrary. So I actually spend a whole lot of time in making sure that things are formatted in the sense that make it easy for a reviewer to look at. One of the ways in R is using the cable or the cable extra package. And this is particularly useful if you have a reproducible R document that you're then going to render to a PDF. What I do end up doing when I work with individuals who are sort of wed to Google Docs or Microsoft itself is I'll either render to a Microsoft document through R, or I'll take my tables and figures and I'll render them to PDF and I'll copy the PDFs in. Because then you can get direct, whatever placement you want with the nice captions. So this is an example of generating a PDF, so a vector graphic table, using Cable Extra. Right? So we started with our cohort count table that we just pulled from the database. I only want to report the cohort counts in this case for users of fluoroquinolones versus users of half Bactrim. In terms of this, I'm going to do some renaming so that the labels on my table look nice. Instead of cohort name, it might be cohort itself. Instead of database name, I want it to be nice and human readable and say database. I want to report the number of subjects. And of course, I want those subject numbers formatted as integers, using, in this case, a comma to separate thousands places. And so if you were sending this to Lancet, you change that to not just a period, but the raised period, right? Which is easy to do with a quick change, with a quick line of code. And here I'm just going to display it. I actually want to do cohort by subject number. You can add the headers and footers that you want to the table directly using Cable Extra. Cable Extra allows you to do the appropriate aligning that you want in your table. I'd like my text to be left aligned. I'd like my quantities to be right aligned. So I can specify as left, right, right, right. Above each of my different columns, the last two columns, I want a super column with a nice line dividing them that's called exposure, which you can put in. And of course, I want exposure and all of my column names to be centered. Also, if I were outputting this directly to a LaTeX file or a PDF instead of to the web as I am here, I might actually want to shade every other line, and shading them with a light gray or even a blue, because we're no longer wed to black and white printing, looks very, very, very nice. But in this case, it's just outputted without the shading, because it turns out that the shading doesn't work very well in HTML when you have these extra headers on there. And I know, first 0th world problems, right? Often for very complicated tables, for example, if I'm trying to pull together covariate balance, where I have several different cohorts, and I have information about the cohorts, for example, before and after a propensity score stratification. So I have lots of columns. The columns need to be formatted in many different ways. I actually just add all of the header and footer information directly in a math typesetting language called LaTeX. It turns out that when you render from R and a markdown file in R to a PDF. One of the intermediates is LaTeX. I have the personal advantage that I grew up as a mathematician, so it's kind of like a second language to me. I understand it's very unknown to many others, but it is it's a direct way of specifying. I want this table. I want the whole table to be centered. Here's kind of the alignment that I want for each of my columns. I want some headers. In those headers, I want mathematical symbols. Like, p-value. P should always be in mathematical, italics, right? So, $P, $dash value. You can do that as well in kind of these reproducible documents. But I'm a little bit of a little excessive on wanting to make sure that tables look as good as possible. This is a good breaking point before we start talking about working directly with the cohort method result table. Are there any questions?
I don't have these. How can I have these in my laptop? How
So,
can I open these?
Yeah, so this is a web document that you can pull down. It's currently at bit.ly sos_tutorial. bit.ly. Oh, that's way too small. Yeah, so that might have been in the email. That might have been in the email credential. It should have been in the email credential file that went around. Did you have that, Jan? Thank you.
Mark, can I just ask the email credential file? Who did it go to?
Folks.
Yeah.
Well, let's keep passing it around. For what?
Anyone?
Yeah, so there was at the beginning, we started passing around a credential file. Let's continue to pass that around a little bit more. So for individuals that have it, just email it over. Other questions? Other concerns that I can? Oh, good. That document is up for you. Perfect. And you can just copy and paste that directly into R. Yeah.
Really stupid, basic question.
There aren't very many, and only if they come from our time could they be stupid.
Where is this information coming from? So he's already run it on Atlas, and he saved it on something, and then that's what we're downloading?
Yes, no, it's a very fair question. So large network studies are executed across the OHDSI network using nowadays using a set of packages under the name Strategist. Strategist has a number of different submodules for doing different type of analytics. The results that are generated from each data source form these tables. Okay, so a common approach when we're dealing with an international collaborative is to take all of these results and to put them on a database server.
And that's on the Google Cloud.
It's probably this particular server is probably AWS. Yeah. You can also you can run this locally. I mean, if you are doing just a local study and there isn't a whole lot of outside collaboration, you could just run it on a server yourself. For example, within R, you can run SQL Server, and it's easy enough to put all of this information up there as well. The SOS challenges, of course, took place across the whole world. There's lots of us. I didn't upload the stuff for Jack, but certainly it was an important way of kind of communicating these types of results. Also, in very large studies, sort of legend hypertension and legend diabetes, where there's kind of multiple papers after over many years, it's nice to have the complete result set in one public place. where individuals who are interested in then coming in and say, actually, you know, we did do some analysis on a subpopulation of individuals that, you know, that we haven't had an opportunity to publicize or analyze yet. How do I get involved? Stretch of a topic for all of us, but it has been you know, kind of I feel a real limitation in moving the community forward. We've gotten very good at, you know, generating large sets of analytic results. We haven't been very good of, like, how do you then change that into, you know, knowledge that gets distributed either, you know, through the press, through publications, through talks. How do we synthesize this? And so this is kind of a start on how we can start thinking about doing that more effectively than we have in the past. There's a huge wealth of information in any of the studies that's gone on. As Jack can tell you, there's all the results from sort of the comparative cohort method, from the incidence rate work, patient level the patient level prediction. But unfortunately, we don't have, as of now, a very good shared repository of functions that take that information and help display them in kind of regular tables and figures. Our shiny, you know, kind of the OHDSI Shiny modules that run behind the Shiny app that you saw before is kind of a starting place for that. But when that was designed, the individual functions for generating the tables and figures weren't made directly accessible. They were nested within other functions. And I personally believe that was a large design choice decision, that a very large, poor design choice decision that we'll have to go through and refactor. That being said, one of the best places to look for R functions to synthesize the information is directly in the kind of the Shiny modules GitHub. But because they're not accessible for use externally, right now you kind of have to copy and paste. There's a link here of kind of an example of where you can find those functions. You know, here is not necessarily from the Shiny modules, but from the, you know, from the Legend Diabetes Evidence Explorer, you know, where the source code for how we get the covariate balance information that you might want to use as a starting point. So it turns out in the thing that I wrote, there is an accessible function called get covariate balance, which is, you know, going to do a lot of the work that we need. So in doing these queries, hunt and peck for stuff that you can pull out of the Shiny modules or from the other evidence explorers. And here's a way of using some of that hunting and pecking. We're going to connect to this public server. In this case, I got lazy and I decided to directly execute SQL. That switches me over to Jack's schema instead of using SQL renderer. And now for a cohort method, as Patrick talked about earlier today, there are a number of different design choices and sensitivity analyses. And in many cases, we're going to execute all of these sensitivity analyses and different design choices simultaneously. So the first thing you might want to learn about in the database is exactly what comparative cohort analyses were executed. And from that, which one do I want to start pulling, you know, the results that I'm going to report from? So I'm going to select from the cohort method covariate balance table all of the unique target and comparator and analysis IDs. So for each target and comparator, there are a number of different analyses. I want to know which ones were executed and a description of what that analysis is. And of course, that description of what the analysis is comes from joining on the analysis table. And then I'm just going to use data table to make a nice sort of interactive HTML table display of all of those different analyses, so, you know, we can kind of pick the ones that we want to work on. So it turns out there were 8 different target comparator analysis comparisons that were made because there was 1 target, 2 different unique comparators, and 4 different methods. And this just has a kind of a description of the different methods. As was described earlier today, the only difference between the methods was what was the time at risk. Was it 30 days, 60 days, 90 days, 360 days? So if you were interested in the results for the 60-day analysis, your analysis ID, which you need to select on, happens to be analysis ID number 2. One of the first things that you might want to display are characteristics about the individuals in your target and comparator cohorts. Think of this as table 1 in a randomized controlled trial. So how are we going to pull that information? Well, I just gratuitously stole a function for get covariant balance from the OHDSI Shiny modules, and above there were some links of kind of where you will find them. And the reason I just stole that is it actually does a fairly sophisticated join across a couple of different tables to pull out the characteristics of the individuals in the target and in the comparator for a specific analysis. And in this case, I'm just going to render the SQL that I stole for one specific target ID, which I could pull out from, we had our cohort table way up here, which will tell you which one you want to look at, versus one comparator in one database for one specific analysis, right? And then this function returns it. So I'm going to execute that. I'm going to connect to the database. I'm going to execute that function specifically for fluoroquinolones compared to the cephalosporin for analysis ID. In this case, I'm going to pull it for just the Veterans Administration results, but you could pull it for multiple databases. And if an outcome were needed for a specific comparison for the joint outcome, right? And now we've pulled out all of the patient characteristics that we know about target and comparator, right? It's no longer go to the Shiny app and you just can take a picture of this table. We actually have all of those values, right? We can compute them. You could go through go through all the covariates and ask what percentage of them have a diagnosis code for hypertension between 0 and 180 days before index, right? This is all of the order 10,000 features that Martijn was, well, I guess in his example, we'll still order 10,000. It was like 58,000 different features that we had about those individuals. And here they are. In this case, I didn't pull all of the covariate information. I just restricted to the entries in the covariate table, so it wouldn't have been gigabytes of information. It's just 100 or so features. And you can now start to interact with these things. For example, what was the largest covariate, the largest standardized difference in mean before propensity score? Was it matching or stratification? It was matching, right?
Matching.
Matching in this case. Well, it turns out they varied most on the Charleston index. Interesting. And after, they varied most in terms of different types of antibacterial uses. Systemic, which is not surprising in this case, because you generally get treated with more than one, or there's a little polypharmacy when it comes to antibiotics. But yet that standardized difference of the mean is still quite small after matching. And this is just a sort of a data table is a very nice way of generating an HTML interactive table that you can use in presentations when you want to sort through different columns and presentations that you want to make. A common question that I have is, I like the figures that the Shiny that the Shiny apps are generating, but I want to do something a little different, right? I want to have, for example, multiple covariate balance tables next to each other in using ggplot, for example, or I just want to, change the colors that are used, or I want to subset the covariates that I'm actually going to display in before and after or in a different format. Well, you have an R data frame here. You can interact with this R data frame just as you normally would. And you kind of as an example of interacting with it, here I generated it's a really bad plot, but it's an example of you actually have an R data frame of all these results that you can use in the ways that best support the message that you're trying to develop. Now, I don't think this is a good way of doing it, right? But I'm plotting the before matching standardized difference of the mean against the after matching standardized difference of the mean using a basic R plot, and I'm using a line. Obviously, you'll want to do something a little more sophisticated, but to reiterate, these are just R objects that you can now manipulate in the way that you usually would. I highly recommend when you save your figures to disk that you save them in a vector graphic format like a PDF, or if you're really old like me, an encapsulated PostScript. Then the reason being is these formats can scale to any size that you want. I immediately see when I'm reviewing a paper if somebody took a screenshot of something, right? Because they took a screenshot and then they scaled it up. And I'm like, that looks horrible. It's totally pixelated. That's not the impression that you really want to be making. If you're not familiar with generating PDFs directly from R, before you call in R, if you're using the regular R plot functions, you just call PDF and give it a file name, then plot what you want and do device off. I'm old. I don't really understand the grammar of graphics. I wish I did. I know all the cool kids are using it, and I highly recommend it. So if you're into grammar of graphics plotting, right, all you have to do is make your plot function, and then just use save, gg save plot, but make sure to give it a vector graphic format, because by default it gives you a PNG, and those just look horrible. Likewise, we can pull out the different effect estimates. We've gone through describing, how many patients we have, who they are, what their age distributions are, et cetera. We might want to report what the hazard ratios might have been. So we can, again, connect directly to the database server, right? And in this case, I'm just going to manipulate everything in R itself. So I'm just going to pull all the results from the cohort method results table. So that's going to include the negative controls for all of the different comparisons, for all of the different analyses. And at the same time, I'm also going to pull the diagnostic summaries. So I know which of these results should be unblinded and which shouldn't be, right? And now I just want to sort of subset these results to those that I might want to display in a nice figure. And in this case, what I'm going to do is I'm going to take all of the cohort method results, and I'm going to only select the 3 outcomes of interest in the study. So the other outcomes would be the negative control outcomes as well. I'm going to do this for in this case, fluoroquinolone versus the cephalosporin for the analysis 2 time at risk. And I'm going to add to those results from the diagnostics table whether or not I should unblind this result or not. Did it actually pass diagnostics? In addition, I'm also going to add my more reader, user-friendly descriptions for the databases and the outcomes themselves. And I've spent a lot of time in a number of publications over the last few years generating a number of sort of custom functions for displaying lots of different hazard ratios. There's neither good nor bad. I'm just using a function that I've used before just to show that you can make some things that are much better looking than just a simple forest plot. If you like the color scheme, I highly recommend you use the R package Wes Anderson. This package, somebody has gone through and created a number of different color schemes from all of its different movies. So you pick your favorite movie, you pick a couple of colors from that palette, you take the alpha level down from 1 to about 50%, and you get something that's nicely displayed, because these are all just R objects. Questions?
Yeah, I have a question.
Yeah.
There is a balance table and then shared balance table. What is the difference? Because I do have less covariance in the balance table rather than shared balance table.
Yeah.
Is it right?
So this is from Strategist, right? Yeah. So I don't have a definitive answer because I haven't looked at the export commands from Cohort method up into the specific tables. But my guess is one has been subsetted to the features that you've included in your make table 1 spec file, and the other is all order 10,000. At least that's how I've how I've stored them before. But yeah, it's there's a lot of unknown there, right? Right. And when I showed the data model, no one who's written down the specs for their different modules is actually given a human readable definition for each of the columns, but we'll get there. We're just kind of up on time. Any other questions?
I want to say that not all people in Odyssey can do this like Mark, so you don't need to be frustrated.
No, everyone can.
I usually make plots by using R code, but I just make a plot and then I just paste it in the Word. I love to use Word.
That's fine. That's fine. Just paste a nice plot in Word. I do that for Google Docs all the time. I understand, because tables and figures in Google Docs are horrible, right? But you can put a PDF in there.
And there are many available code to make some documents like this in Odyssey Gita, so you can leverage them. You don't need to write your own code from the script.
No, so that's a very good point, and one that I forgot to mention is that this whole HTML actually comes from an R Markdown file. So a direction that I'd like people to start considering is you don't necessarily have to use Markdown, but any other type of sort of reproducible, expressive languages. You can write your paper or report or slides and your analysis all together.
And lastly, if you first time, it's hard to write an R code like this. But after the first challenge, then if you keep doing research using Odyssey Network,
Keep working at it.
Yeah, at a second time, you can reuse your code. So it's going to be much easier for your second study.
Good.
Or third.
Thanks very much, Matt. That's
Yeah,
fantastic.
thank you.